In this exercise, we're going to add some things to the output of the comparator. Hopefully you got everything working from the previous exercise. Some common mistakes: if you were having trouble, remember that the ground symbol here means that these are the same point. So you need to have the common from your small breadboard connected to the common for your medium breadboard. So these two commons have to be tied together. They're all the same point as the symbol shows. So that's one thing. And make sure you do that worksheet that lets you experiment with changing the position of the photosensor. It could be down here. It can be in the high side or the low side. You can also bring it to the plus input or the minus input. So these inputs, can change. They can switch. The potentiometer could go to pin 3. And we call this the reference voltage, by the way, coming from the pot. That's V reference. It's the voltage that the comparator will use to compare the voltage coming from the sensor. So do that worksheet to be sort of up to speed on how all your options. You can orient the sensor in either place. You can bring either one to either pin. So those are some things you want to make sure you're up to speed on. And what we're going to concentrate on in this exercise is adding things to the output here. Previously, you would have just monitored that with a scope, but we're going to add some things there. Let me get this out of our way. And as it sits here now, the output is not strong enough to drive very much current. I think the maximum current you could switch through this internal transistor switch is like 20 milliamps. So we're going to beef that up a bit, and we're going to do that very simply by adding an FET transistor. And we'll talk just briefly about what that is. But it looks like this, the schematic symbol for an FET transistor. It's a little intricate, but we'll learn these actually more fully later. It's here's what we're adding. We're adding an FET, and it's actually the BS170, which actually we'll learn more about in the spring. It's an N channel, which you don't have to know all those details, but we'll get the pins for you so that you can actually wire it up. It is another transistor switch with just SPST action. So here's the way it's going to look. There's going to be it's a 3-pin device. The gate, you can look at the spec sheet. It's posted in the Teams under files on week 8 in the lab folder. So we've got the gate, and we've got the drain, and we've got the source. And those terms come from old days of vacuum tube technology. But there they are. So follow those pinouts from the spec sheet for the BS170, and that'll help you get it in the right spot. We're going to use the output of the comparator to turn on and off this FET transistor. Remember, the output, thanks to our pull-up resistor, it goes high when this switch is open, and it goes low when the switch is closed, when this internal switch is closed. So we have a high and a low generated for our FET transistor, which does respond to voltage. So our high and our low here will turn on and turn off the transistor. So when it's high, that voltage will actually turn on the FET transistor, and by on, I mean that the drain to source path will be complete. So it will actually look like it's closing a switch from the drain to the source. You can just think of it as a switch. From drain to source, it turns on a path that will conduct from drain to source when the gate has voltage. When it has the 5-volt signal, it's a field effect transistor is where it gets its name, where the abbreviation FET comes from. And that voltage field at the gate is what turns on the path from drain to source. We'll learn more about that later. For us now, that switching action can turn things on, and it can handle higher currents from drain to source on that FET. So the higher currents absolutely are or something we can use now. I'm trying to remember what the maximum is. It's hundreds of milliamps that the FET can switch. So that means we can now turn things on. We could put a little lamp here, okay, and I think our little 3-volt lamp, that little bi-pin lamp we've used for exercises, can handle the 5 volts. It'll maybe torture it a little bit, probably shorten its life. We could use that if you want to. I probably have some other lamps I can dig up too, if you're worried about that. So, but we have the capability now of switching a lamp on and off with that FET. And so you can try that out. And what you're going to try to do is set up the sensor and the comparator for what we'll call a dark on circuit. Okay, let's try that. So in other words, when a certain amount of darkness comes onto the photocell at a certain level of darkness, which is set by the reference voltage, right? The lamp will turn on. You'll turn on a light. So it could be getting darker, darker, darker. And what you want to test your operation is just keep shadowing the photocell until your lamp turns on. Now, that's going to mean you're going to have to reposition this. Because look at the operation now. If you leave this photocell here, as you get darker, the resistance goes up here. So the voltage goes across here, increases, which means the voltage here decreases. And this is your output voltage, always remember that. So voltage decreases with darkness. Decreasing voltage at the plus input means eventually you're going to, this one's going to win, the minus input. And when the minus input is winning, the output is low. So you're going to have the opposite effect here. You're going to have, under a light condition, the light will be on. And as it gets darker, the light will turn off. We want the opposite. So one way to achieve the opposite is to take this photocell and switch places, right, with your fixed resistor. So that voltage divider, you can flip that, put the photocell down here, and now it'll work, right? So if you want, I can draw that. The other way you could do it is you could just flip these inputs. That works too. Switch these inputs. Don't do both, or you've accomplished nothing. You've just undone yourself. What you did here, you can undo here. So you got those two options. Again, do that worksheet if that didn't make sense to you. Let's go ahead and clean this up a little bit. So what we're saying is that our fixed resistor needs to be here to reverse the operation. And let's check it then. I'll get this cleaned up a little bit for you. Okay, so we've got that, we've got this, and then let's have a look at it. As darkness comes, as it gets darker, the photocell's resistance increases, which means the voltage across it increases, which means the output voltage of the voltage divider increases, which means the plus input voltage, the voltage at the plus input, increases, and it will go past what this voltage is. So you can set this threshold here, this reference voltage, so that at a certain level of darkness, pin 3, the plus input, surpasses pin 2, whatever you have set here. When it does that, the plus input is winning and the output goes high. And have that association in your head that the plus input winning means you go in the positive direction, the output goes high. Minus input winning means you go in the negative direction and the output goes low. So we said the plus input's going to win. It's going to surpass whatever threshold you set here with the reference voltage. And that does represent a certain level of darkness, right? This voltage. And when you get past that level of darkness that you set here, the plus input wins, turns on the FET, turns on the light. So you can set the level of darkness with your potentiometer that you want this light to turn on at. So we have a dark on circuit. The darkness is what will turn on that lamp. So nice. So there you go. And you can try it out. You can monitor things. We have 4 channels on the scope. Let's see what else we might want to monitor. You could still monitor the high and low here if you want to with channel 1, with channel 3. Why not? We've got the channels. You can monitor the status of the transistor switch pretty easily right here. Let's see, right here. I'm just looking because we only have one scope common, and the scope common is circuit common. So I'm looking across my transistor switch. So now you have to get used to that, when the switch is on, do you remember what kind of voltage you see across a switch that's on? It's low voltage. And when the switch is off, it's like an open. So you'll see on channel 4, you have to remember when you see voltage on channel 4, that means the transistor's off. And there'll be like an open from the drain to the source, so all the voltage will be there. When the transistor's on, you won't quite see 0 volts on channel 4 because there'll be maybe a couple tenths of volts across the transistor still as it's on. That's the best it can do. It's not quite metal contact, so there's going to be a couple tenths of volts maybe still across it even when it's on. But remember, that's how you monitor a switch, whether it's on or off. So remember that. And what else can we do? So you can demonstrate this for me when you have this done, the dark on circuit. I want to see that lamp turning on as darkness occurs at a certain threshold. Another one that's fun to do while you have the dark on circuit operating is you can change out that lamp. I'll see if I'm pretty sure I have some buzzers. Okay, so a little 5-volt buzzer, and I'll see if I can scrounge some of those up. Should be available for us. And notice what we're doing. I mean, we're switching whatever we want to switch. That's where we put it. We put it right here. We're switching the low side. We would say perhaps whatever you want to turn on and off, you give it the 5 volts, and the FET transistor provides the switching action to connect the 0 volts side to the device, what we call the load that you're switching. Look what happens now. What I'll do is I'll have a buzzer go off when darkness occurs. So what's useful about that? Well, let's see what we can do with that. We can take a little, I think I have a few little laser beams, or if you have a laser pointer, you could bring that in. But we can have some kind of little device here that shoots out a laser beam over to the photocell. And that'll establish a certain light condition based on that laser light hitting the photocell. So then you can adjust your threshold here, your reference voltage, so that it's maybe a little bit above, I guess, right? The voltage here will be a little bit above, so that whatever voltage is here under the laser light condition, you'll have this voltage a little higher so that this input is winning and the buzzer's off. And then what will happen is, if you break that beam, we basically have a photo switch. We have a little maybe doorbell or whatever. It's a little alarm that when the beam is broken, this through beam, we have a through beam sensor is what you would call it in the industrial world. But we have a through beam sensor now. When the beam is broken, the buzzer will sound, because if you break the beam, the photocell goes darker, right? When the light is interrupted here, the photocell will go darker. That darker condition will increase the resistance, increase the voltage to pin 3, and you need to have your reference voltage set so that when the voltage increases at pin 3, it goes past the voltage at pin 2, right? And so the plus input's winning at that point, which makes the output go high, which turns on the FET, which turns on the buzzer. So you have a little alarm here that'll go, or a little doorbell, or whatever you want to think of it as, right? It kind of starts sounding like a kid's book, doesn't it? Reminds me of the kids' books I have to read to my kids. The light hits the photocell. You break the beam, the photocell goes dark. The dark photocell makes the resistance go up. The resistance going up makes the voltage go up. The voltage going up makes the output go high. The output going high makes the FET go on. The FET going on makes the buzzer sound. Was that unnecessary to do to you? Sorry, I do that on a daily basis. Okay, so I think that wraps up the exercise for now, and then we'll see what we want to add next. But that'll be, I think, a good next fit. Sorry I read The Old Lady Swallowed a Fly to you at the end there. That's kind of what that probably reminded me of. All right, I think we'll wrap it there, and then we'll just make another short video when we want to add the next thing to it. Just looking to make sure we didn't forget something important. Buzzer. And you can definitely show me the lamp going on, the dark on. If you get a laser going, sure, I'll have a look at that too. You don't necessarily have to show me that. It's pretty much the same thing. Okay. All right. Well, if I forgot something, I'll pick it up in the next video.